Let's see. Let's see where we are at. Maybe there are things you felt along the line that I should just retouch. I'm teaching two things very important today. I'm teaching 3D sketches and I'm teaching part optimization. This is purely engineering work today. Part optimization is purely engineering work. It's not just design. It's ability to be able to run some certain analysis to optimize parts. That's one of the things we'll be doing today. At least those two, I believe by the time we'll be done with them, we'll have known that we have learned something very significant in today's class.
Okay.
So can you share some things with me that you have been doing? Let me know.
Oh, okay.
Should I make you host, sir?
Let me just open and share some few.
Is it on WhatsApp or on?
No, here. Like
so I have to make you host. So
yeah, I'm not trying to open it anyway.
Yeah. Now it was proud to that time, Sha. I was checking our this and I found out that okay, composite cups is still open for us to talk about. Photo view rendering is still open. We need to talk about that. Boundary base and boundary cuts. There's the 3D sketches and 3D planes on SolidWorks. Then that part of optimization that I talked about. Let me find the day that I'm supposed to have done it. Okay, design studies. Design studies have to be done. Then I think if we are done with all those things, we are good to go on part.
Okay. Yeah, it's open. Okay.
All right. So sorry about the princess issue.
Yeah. Oh, it's okay. It's okay. I'm trying to share my screen.
Life sometimes can be just like that. Okay, wow. You are even generating drawings already. This is SolidWorks drawing I'm seeing.
Oh.
Now it's drawing.
I moved the file.
Wow. Wow. You did all this by yourself?
Oh yeah.
Wow, I'm impressed.
I needed to build this for the company to build this for me, okay?
Okay.
So
and you're able to even do the assembly by yourself, Shay?
Yeah, let me send you what do you call it? I should think it's on my tablet. I'll send it to you along the line.
Okay.
Yes, I'll send it to you. So they finally bought it anyway.
Wow.
Yeah, I will send it to you.
This is interesting. Did you feel that there is confidence level that you have been able to learn some things and you have been able to do some things?
Oh, it was okay. Sometimes, you just have to be, doing some one or two, you get it here and there, like try and error kind of thing, but it works out. Yeah, it works out.
Because I really want to evaluate if I'm doing well at all, if there's something that I need to do that I'm not doing.
Oh no, it's okay. It's okay. I think we only have to get enough time, like to be discussing some of these ones, and also some of the challenges along the line. It's unfortunate, like you understand, maybe your schedules wouldn't permit my schedules as well. Sometimes you close from the factory. The other time, for instance, I was coming, I realized that we could not find a key. we have to be searching here and there. These things happen, but I think it's okay. We are on course. The most important thing is like to have enough time to be practicing each and every day.
Because
Besides that,
my concern is
hello.
that I want to be so sure that I've been able to deliver
Oh
even more
yeah.
than your
Yeah, I
expectations.
understand. I understand.
I'm
It's
concerned
okay.
about that.
Yes, that is
Any
okay. That is okay.
any job that you
That
are
is
being paid for, you should do it well. So
no, that is okay. Yeah, that is
that's
okay.
my concern.
Like I said, there are some few challenges here and there, but then it's okay. On my part, for instance, I need to, practice them more. But like you are multitasking, you understand? You are doing
Yeah,
this, you are doing that. So
just like
it
that.
wouldn't be like,
It's like
okay.
that for everybody. Yeah, myself, I have a lot of things to attend to do and to, but we just have to get over it. One of the painful things is that some of these things are things that somebody should have been introduced to when we still have a lot of time in our disposal, when we are still much younger and there is still time. But it has happened that way. Any other job that is available at all, any other design that you have done that is available that I can see. Hello? Hello?
I'm with you. I'm with you.
Is there any
Hello.
other design that you have done at all? Other than
Oh,
this one? You can just do R, press R on your keyboard. All right, okay, you can even wait. Can we discuss? Don't worry, just leave that one. We can discuss. Let's discuss. You can click on the stand that carries that dust and the dust stand, then open it. The very first options from that dialog. Okay, you can even, the very first option, click on it. No, the very first options on that thing that shows on the screen. Yeah, you can do it from there. Wait, click on the stand now. There is a quick stuff that used to display, and that thing that almost showing now. You don't get it. It's showing faintly. Click on it. Okay, right click on it. Let's do right click. No, go back. Right click on the stand, yeah, and open the very first option that look like a file. Yeah, that's how to look open the part. So let me ask some few questions. Did you think this thing is manufacturable like this? Hello? Are we together? I can't hear you. Okay, you are muted though. Your mic is mute on Zoom. The mic is mute. Please unmute yourself. Your mic is mute. All right.
hello.
Yes, we are together now. Yeah. My question is, did you think this is manufacturable?
Oh yes. Now this is what I wanted anyway.
I understand, but did you think this
Uh-huh.
is manufacturable?
Yes.
How?
Oh, by just submitting this to them.
They know
Okay, the
what
drawing.
I understand that they know what you mean.
Yeah.
But what I want to do this morning is that I want to actually take from the plane of SolidWorks to the plane of
Okay.
engineering. That's my job this morning.
Mm-hmm.
This looks like it's fine. For example, the 4 legs, they were just angle iron. You know angle iron profiles.
Yeah.
So that one is manufacturable. But the other part, it's for what you actually want to do. It looks something that is not really necessary, because to generate that part that carries the dust tank itself, you are saying that this place, you should find a thick metal and you should actually mill the center part out,
The
or you
center.
use
Yeah.
plasma cutting to cut it off,
Mm-hmm.
or you use
Mm-hmm.
any of these methods to get it cut off. That looks like a bit very expensive to do in real life. I am
Okay.
so sure that the Chinese will not produce this way. I am
They,
so
they, they
sure.
came out. They came out with. I think here covered
With what?
with this one like not removed. It was
Yes. I know, and they just put a flat plate there, a flat sheet
Yes,
there.
yes, like straight.
What
Yeah.
I know they won't use this This thickness is big.
So there was here was 800.
I mean, the thickness of the sheet metal, the metals they use.
So small, like
Yes,
five.
like five
Okay.
mm. Yes, 5 mm bone serve is
Five
big.
mm. Yeah.
3 mm should be fine for this work, from what I'm saying, provided that what is carrying is tank. So
Yeah.
this is actually and the other side, they will definitely use an angle iron cross sections to do on this side. They will not use.
Exactly.
They will not use that. This is engineering. So
Okay.
I will do my design this morning. You understand? I will
Yeah,
be
with
using
you.
this to introduce you to 3D sketches, then
Okay.
and SolidWorks Weldments, a bit of SolidWorks Weldments. Then you will see how I'll be able to generate a drawing that is practically oriented. So you can make me a host, sir. That is practically,
Okay.
that is practicable, that it's realistic. It's not just one of the places I want you to push to in this particular career we have chosen is that push from the edge of I just designed something that is nice. Push to that edge that I designed something that is production that is practically producible.
Yeah.
That's what one of the issues I have with many designers. They just want to design something that is, yes, it's fine, it's good, but outside the world, the technology does not even exist. Or if you are going to even do that, you are going to pay a lot of money to
It should be
achieve.
expensive.
It will be expensive because to actually do this is going to be very, very expensive to be able to produce something of this nature. So you can stop sharing the screen, then you now make me a host, then I'll now redesign it in a particular way. Then you now see the difference. So I'll be introducing 3D sketches, then I will use them, where I find them useful. And I really, really want you to also know that.
Okay.
So I really, really want you to know that it will be of a great joy to me if you can actually try as much as possible to leave that realms where designer want to stay. They want to design something that they don't really have a knowledge of what is available in the market.
Yeah.
Especially I know you are from Ghana and from Nigeria, in a country that are not extremely advanced in technology. That some things were not really practically possible. And if you can even achieve it, you achieve it with a lot of cost. I work with a guy from Israel. He's one of my mentors. And the guy
Israel.
Yes, Israel. His name is Ron. The guy taught me a lot of things. He exposed me to actually thinking from the concept of manufacturing. I can show you some of my work. And I will tell you that this work, when we finally printed it out, there was no bolt holding it.
Oh, okay.
The parts were designed to fit into each other perfectly without, I'm telling you, without glue, without gum, without anything, everything works perfectly.
Oh,
And
okay.
within the availability of what we have on ground. I'll share you some of my personal innovations today. I'm working on my product. I will share some of them with you. You will see how parts are coming together, and they were coming together in a very engineering manner. And that is what I really, really, besides you learning SolidWorks, it's of no good, not reasonable good, if you can just design something that is practically impossible.
Yeah.
I've always been telling my second that I need them to shift from that realm. Yes, you know SolidWorks, fine. You can do extrude, you can do this, but outside market here, nobody understands extrude. That's just the truth. They don't understand what is revolve. They don't understand what loft is. They understand processes that are common to them. So, so what is 3D sketches? We've always been doing, so this is just an introduction to 3D sketches. We've always been doing sketches on a plane, on a surface. I will lift a chair up now. Let's say I want to sketch the whole chair from beginning to the end. That whole table, you have discovered that you start your sketches from a particular plane, then you need to move to another plane, you change your plane, to that plane. So instead of doing those things, there is a way I can do only one sketch, and it will contain everything in one. So this is what I'm talking about. You can always be sketching on this ATM, on this plane. But when I need to add legs to this, and I want to do everything in one single sketch, that kind of sketch is what we call 3D sketches. It's a bit different from 2D sketches, and to start 3D sketches in SolidWorks is a bit different from the procedure to do 2D sketches. In engineering, I found out that few choices like trusses that carries water, borehole tanks. I know this thing should be in Ghana also, because water reservoirs that people in the house, they are putting, I might share some of my work, some of the work that I did that is even in market currently now. Some of them that have been produced, and I follow the process, the manufacturing process from A to Z.
Oh, okay. I will come now soon. This one is talked outside.
So,
sorry.
No problem. I understand that. I follow the process from A to Z. So you will be able to now have a very broad visions of things that are, it's true that are not really perfectly in market like that. Let me be very sincere with you. Revolve are not really perfect in market like that. People don't know what this means. In short, I took some certain steps about my life that I want to be extremely good in what I'm doing. So I used to go to markets, to where manufacturing process is being done, to see what is being done when they want to achieve a particular result within the limits of what is available in the country. That's very, very important. You will understand the difference between China and Nigeria, and China and Africa the moment you leave China. There are things I want to discuss with you on a personal ground that is totally different from design. There are available parts in China that if I'm taking AliExpress, you can easily walk to a store and say, I need this to this specification you wanted. But here in Nigeria, you just have to work with what is available. I'll give you an example. You want to design.
It's same in our context, okay?
Yes.
Like for instance, with this kind of project, I've been to some let's say local manufacturers, okay, those who are working with CNC machines.
Yes.
And if you look at the parts, these guys are building up, and sometimes you ask yourself, like you marvel when you see those ones. It's like, how are they able to come out with this design? How are they able to come out with this kind of cutting where even those of us in the factory are struggling to cut some few pieces? So you get it. So it's same in our context, but sometimes like you cannot complain so much when some of these things happen.
Let me give you an instance. You need a gearbox because you want to change the motions by 90 degrees. A shaft is rotating this way, and you need that to actually go this way. What is done in Nigeria presently is that you find the differential gearbox, that back axle, the rear axle of a car or a vehicle. You need a motion. You have a motion this way, but you need it this way. So you need a 90-degree turn for it. So what is done in Nigeria is that you went to go and get a rear back axle. This is where the propeller now comes in, while this is actually going to one of the wheels. So that's how it's done in Nigeria. Instead of you don't have the gearbox. Even if you can get the gearbox, you don't have the right capacity, the power. And if you find out the cost of this, of the rear axle, is actually cheaper than the cost of a new gearbox. So a lot of complexity comes in. So these are what you are going to be designing in Ghana need to know. And you should be able to fix it into your market and be able to come up with something solution. So I'm going to start 3D sketching. Starting 3D sketching, I believe my screen is facing.
It's shared,
So to start 3D sketch, you don't start with a plane. You don't start with maybe front plane, top plane, because you are not actually starting from a plane. That's just the basic thing. So you go to sketch. This is future where we have extrude. You go to sketch. Yes, ma'am. Okay, ma, order, ma. So you go to sketch, then you go 3D sketch. There are two types of sketch. The 2D sketch is the one you draw on the screen. Then you go to 3D sketch.
The direct one, okay.
Yeah, I need to explain some theories and explain how some things happen. Okay. SolidWorks is y-axis, this up as y,
Yeah.
this is z, and this is
Z,
x. It's
X,
showing
yeah,
now here
Yeah.
y, z. So peradventure I want to start my sketch and I want to draw a rectangle like a table you just designed now.
Yeah.
I'm going to start on a plane called ZX plane. A plane like this. So let's do a test, just a test, a simulation now. So this plane will be what? This plane will be YX plane. This is Y and this is X. This plane will be YZ plane.
Yeah.
Why this will be ZX.
ZX plane, yeah.
So I want to start. So I need for your table that you design now, I need a rectangle on ZS plane. A rectangle on ZS plane. So what I will simply do is I will go to my rectangle. It's still the same procedure. So as you see my screen, I believe my screen is visible. You are seeing
Yeah.
It's telling me that
there.
yes, it's
XY.
telling me that if anything I draw now, I'm on XY plane. But that was not my intention. My intention is to actually draw on ZS plane. So the secret here is to press tab functions on your keyboard.
Tab, okay.
So it changes to YZ. I believe you can see it that it has just changed to YZ. Then you press ZX. That's where we are. So I'm now on ZX plane. A plane just on the table, flat, just like in a real sense, a top plane. That's very simple like that. ZS actually corresponds to top plane.
The top, okay.
So I will take center point rectangle that I wanted. I create just the same the first point, which is at the origin. This place is now the origin of all the, this is now the line, the Y line, and the X line. So I'm taking that origin and I'm doing this.
Okay.
Very simple. So I'll begin to introduce some constraints. Like I want this to be along Z. Please, you need to understand.
Okay.
That line is going parallel to Z axis. So I want it to be along Z axis.
Okay.
So I want this to be along X axis.
Yeah.
Then I can begin to add my dimensions. Let's just make it 8. You said it's 800, Abby?
Yeah.
And what?
500.
500.
Yeah.
See, the moment I did that, it's fully defined. This is a 3D sketch. No matter how you look, it's still a 3D sketch. So the next thing is to add the legs. The 4 legs. So I'll take line again. But this time around, I'm not sketching on ZX because the legs were not on ZX.
Yeah.
So the legs are
on
XY, XY, and YZ.
Or YZ.
Yes. So I did this. That's the first leg. I'm making it a bit simple this time around because we are just starting. So that's the leg. So I will turn.
Okay.
Like this, still one single sketch. Then I can pick my tools again. SolidWorks is a bit smart.
Yeah.
It's smart in that in the sense that if I actually turn YZ plane to myself, it will know that I'm on YZ. Then you change it for me to YZ.
Yeah.
You see? Now I'm on YZ. You see, it changes by itself.
Automatically,
automatically by itself. But if it doesn't change, you use your tab key to go to also because sometimes you have a complex job that the system doesn't recognize that you're actually changing a lot of things like that. So in those cases, you just have to use tab functions and change it by yourself. So this leg must be equal. Then introducing, I'm holding my control key currently. The normal thing we have been doing also.
Okay.
I put equal relations to all of them.
Then a dimension, okay.
I've not even given them dimensions. Whatsoever,
I get it.
You understand? Whatsoever one, you can see my screen. Every other ones are taking order because I've already told them there's equal relations between all of them.
Okay.
So the next thing is to add the dimensions to this young one.
Okay, 500.
Yes. Dimensions. So it's 500, yeah?
Yeah.
So that is a complete table in just a single sketch. So you have the front view, you have the right view, you have every view you want. I'm very, very skeptical here, and I'm very, very sincere here. In most all my machines you find on GrabCAD, they are 3D sketch, especially their frames. Frames are always in 3D sketches, because I find that that is the best plane that is easy. I'm going to show you some of my work. You see that they are, you discover that designing a frame of anything is easier on 3D sketch, and I'm going to show you how fast this will be.
Okay.
So I'm not going to use extrude to do my work here. You can do extrude here, it's fine.
Yeah.
But I'm going to use SolidWorks Weldments. I'm going to be introducing
the Weldments,
so Weldments is already showing here. So I will exit the sketch now. I'm fine here. So it's saying structural members. Weldment, structural member. Weldment just means that those places where you actually add welding to it. So structural members. Now, here is the sweetness of the whole course. I'm very, very sincere. SolidWorks has all the sections of available that people that produce iron, that produce steels. They have SolidWorks has all of them, and it is also possible that if there is an upgrade in market there that doesn't come with your version, you can go online here. I might also teach that today and download the latest sections that's available. Provided that you needed that, it's possible. And I will show you. I think one of the courses also I put SolidWorks file directories. Is one of the things we're supposed to talk about. File directories. Where does this file come from? Where does this file come from? Where does SolidWorks put this thing from? This is just a computer system that is just looking for the locations to pick one or two things. So ANSI inches. So we have ANSI inches, we have ANSI metric, we have ISO. If you download more, these are the basic one that comes with SolidWorks. If you download another particular like BMI for British people, a lot of for German, for Japanese, Japanese definitely they use a different procedure for their manufacturing, and generally the world respected them, because if you are looking for anything quality, then you go Germany or Japan. This is no so.
No truth about that. Yes.
There's no, even China is just coming up. Those guys are just using population. Germany, Japan, you have the quality. You have the quality. Our leaders in Nigeria was unable to buy things from Germany or Japan because it's always quality and expensive. Because Germany and Japan believe that whatsoever they can use, they can produce. They can sell it out. So you find a lot of Japanese products in US than Chinese products. So I'm using ANSI inches, then type. It's asking me, am I using angle iron to produce this? Am I using C channels to produce this? C and U channels, they are the same thing. Are you using a pipe to do this, a rectangular beam, a X sections, a square tube to do this? Anyone you are using angle iron to do this, fine. What is the size? There are different sizes of angle iron, 1 inch angle iron. That's 1 inch by 1 inch by 0.125 inches thickness. Then we have 2 inch by 2 inch by 0.125 thickness. We have 2 inch by 3 inch angle iron sections. So anyone you select, you are good to go with it. Then I'll just be using 2 by 2, for example. Then all you have to do from this junction is to actually start clicking on those things. You see how fast it is. Just follow me. This class is not. That's how I need the legs to be. Then so with this, I'm done with my stand. So then I go to structural again, do the same thing, basically the same thing. So
Okay.
So I believe this is the better version of what you want to do than what you did. A common
Yeah,
welder
yeah.
in the market can do this.
Yeah.
That's one. You will need a milling machine, a complex process to actually do.
Yeah.
So,
Yeah, I get it. I get it.
so this is
Okay.
actually the way to go around all this. Let me quickly open some work, recent work. Let's see. Okay. In short, these are complex ones. I want to actually open something that looks a bit simple, advanced. Okay. This should be the workshop in drawings. And I will open it. So, is my screen visible? Is it showing?
Yeah.
This machine was actually produced, and
Okay.
I might show you also his real pictures in real life, how it looks like. Because these are so this particular frame now. Let me open. I think I can open it. So this part now, the frame. Okay, yeah. Yeah. So this is how the frame looks like.
Okay.
That machine. And let me show you the 3D sketch. Edit the sketch. You can see it's a single sketch.
Okay.
It's a single sketch that goes that way. So it can be that complex. This is one of the simple ones also. I don't want to
This is simple.
This is simple, very simple.
Oh, really?
Yeah, this is very simple. But you just have to follow the whole process step after step, step after step, step after step. You will definitely arrive there. You can have jobs that are extremely complex than that, than this. So in doing, let me see if I could find this also. Control open. Let me show you one of the complex ones. I have a guy here that has a fabrication company in Nigeria that I designed for. So let me see if I can find a very big trusses work. Okay. So the guy is doing well. Anytime he give me work, I'm even begging him for work now. I'm always happy. So this is one of what we are talking about. I believe it's showing small now. It's okay. If I decide to, this building was done in Nigeria. So you can have a lot of trusses that is coming together. I think this is showing a lot of things done. Let me find another one. And I think this is also, you can find some here. Fabulous engineering. So this is another one. Is my screen obvious? Is my screen?
Yeah, I can see.
So let me try and open it in a few seconds. Then we'll still go to 3D sketch again. I'll still do it again.
Okay.
I just want to show you that this more realistic way of getting project done. So far, it involves structures that carry stuff and the rest like that.
Yeah.
So just try for it. It's hard, but it will give you a very good edge that you can design and you can actually supervise and ensure that to the extent that what you design, you see it in real life. That's one of the things I always put online that is my advantage in life. That I believe that I don't just, it's not all these common guys that just design something online and it's not physical, it's not realistic, it's not something you can actually lay your hands upon and see it working in real life. That I want to design a part, a machine, and I want to see it working. I'll show you one of my, I think one of the climax job that I did, the machine, the design of the machine, I'll show you today. And it's also done, the frame also, when I finish building it, I will share the pictures with you, the video of it working. It's an hydraulic machine and it's very complex. This is taking time. 3D sketches are very good and they were interesting. They lower the stress of your work and they make the work realistic. You can give it to somebody. Yes, this is the trust.
Yeah. Okay.
So it's just a normal. I'm praying for such kind of job now, Sha. We are going into election season in Nigeria currently now.
Okay.
So election will start for my state here. It's starting next year. For the whole nation, it's starting next 2 years. So politicians at this junction, they will be giving out contract of building water borehole for people so that they can receive, people can vote for them in this new places. So I'm praying for such kind of job currently. You can see the base of the stuff being tied down, welded with this. I need to get a source of power very fast. I guess my laptop is going. I don't even know that they've taken light for a long time. It doesn't report to me. Seriously. I'm telling you, seriously. So this is the edge and this the trusses. You can see all the ions coming together, these H channels ions coming together to form it. This is exactly what we are talking about. If you are an engineer, you don't want to concern yourself with anything like welding, you can give this drawing to a roadside welder there. You can, from here, you can know the length of all the ions you needed. You can be able to give you quotations of what you needed for a job. This is basis at which I get quotations, basis at which I get the prices. All I just have to do is to go outside there and ask people, these particular sections, how much are you selling it? So the moment they give me the price of it, I'll be able to give right quotations to the person I'm doing the work for. So it's fine. It's so, and this is also driven by a 3D sketch. The whole process is driven by a 3D sketch. So from beginning to the end, the ladders and everything is done by 3D sketch. So it's highly interesting and it's very necessary for me to talk about them. It's needed in engineering. And people will definitely respect him for it because so sorry, please let me just get a source of power. I'll be back, let's say 10 minutes. Yes. I don't know that they've taken light for a long time. I will make preparations for it. All right, thank you.
Okay.
Sorry, the laptop will go down now. So